Ladies and gentlemen, good morning. As you know, WNE dedicated really a focus especially on digitalization. So it's my pleasure to welcome Bruno Boccard and his guests for a panel discussion on digital in maintenance activities. So welcome Bruno Boccard and his guests, and have a nice panel discussion, gentlemen.
Thank you. Thank you for joining us for this discussion on digital serving new build and maintenance activities. My name is Baptiste Le Sueur. I am the Chief Digital Officer for Boccard, and I will be your host for this coming hour. First, don't hesitate to send us your question live. You have send the text message at the numbers on the screen. You have also an app. So we are very keen to answer your question at the end of this session. We are very pleased at Boccard to welcome our contributors on stage. First, Bruno Boccard, of course, Chief Executive Officer at Boccard. Thank you for joining us. Mr. Vincent Champin, General Manager of General Electric European Digital Foundry. Mr. Franck Grimbert. Franck Grimbert is the Product Portfolio Manager for the maintenance business line at Framatome. And Mr. Christian Sora, Bilateral and Institutional Relation at I2EN. That's it. So please take your seat. We will start just now. Mr. Boccard, I will ask you the first question of this discussion. As I said, you are the Chief Executive Officer at Boccard. We are celebrating the first 100 year of Boccard. What a great achievement. That's really awesome. And I think that it's at least half of this 100 years have been serving the nuclear industry. You will tell us more about that. My question is more how Boccard is setting the digital transformation for serving the whole fleet worldwide, and how do Boccard approach to deliver the real value to all the stakeholders of the nuclear industry?
Well, thank you very much, Baptiste, and welcome to our panel discussion. First, I would like to say merci to all our partners and employees for this amazing milestone for Boccard as we are celebrating our first 100 years this year. The company was founded by my great-grandfather in 1918 in Lyon, and now we're in 36 countries, serving 8 markets, nuclear being one of the major ones, with 4 key trades: engineering, manufacturing, construction, and maintenance. And digital has been a key aspect in our transformation, not only on the way we design, manufacture, construct, and maintain, but also in the way we offer new solution, new value to our clients. So we have 2 approaches to the digital solution, which is a clear game changer for the entire industry. And we've been on the forefront with our team and our partners in finding the right solution for each market. On the inside, we have a safe approach. We want to be entirely seamless and reduce the delivery time by improving through digital solution the reach to the market, to also offer with the data that we encounter, offer better value to our clients through a more predictive maintenance approach, thus improving the return on investment for our clients' assets. And because we're able and willing to follow our clients' life investment, we are putting the digital solution in the center of our solution.
Thank you, Bruno. I will turn to Vincent Champin now. Vincent, as I said, you are the General Manager of General Electric European Foundry. Before you tell us in 2 words what the digital foundries are, and I will ask you a question about your experience. You are lucky enough to have 1 foot in the nuclear industry, 1 foot in other industries, And that's what interests us today, because we wanted for this discussion to have a real global overview of the digital transformation in the industry and what it can really add for real value in the nuclear industry. And my question is about the feeling you can have, or the analysis you can have on the fact that our enterprise of our domain in the nuclear industry have really changed the way they are working. Did our industry already make the switch to the digital world?
Thank you very much, and thank you, Bruno, for your birthday. 100 years, not every year. No, so before I come to a question, which is a fair question, and how fast is digital growing in this business, and where do we see the biggest value? Just a few words about the digital foundries. So, as you know, General Electric and Alstom, ex-Alstom, which we bought, we are very present in the equipment business. And in this domain, if you take our aviation business, for example, we've been using and developing this digital solution for decades. What we understood almost 10 years ago was that the way digital was changing industry was accelerating, and that we did need to organize ourselves in a different way. So, for example, if you take a gas turbine or steam turbine, typically you'll have 1 or 2 plants in the world, and then you ship the turbine whenever it's needed. For digital, you need to be much more localized. So you need to have your best data scientists, your best engineer closer to the customer in the region. If you work on cloud solutions, there'll be local, national, regional regulation you have to comply with. So we needed to localize ourselves in a very different way for the digital space. And that's why we created the foundries and what the foundries are doing. Foundries are the places where you'll find the engineer, the data scientist, the experts that will able to co-create and work on the specific solution you'll need in your industry. So our architecture is having a global supply chain for the machine, a few big global applications like APM to monitor assets, for example, that are designed globally, and then locally, anything that is needed to ensure that the cloud is secure for our customer and comply with its regulation, anything that is needed to find the needles of value in the stack of data, that's done locally with the people in the foundry. So this gives the foundry a very great observatory point on digital transformation. We have 300 visits from different companies, very often at executive level, each year. And we really see different speed at which digital is changing industry. And if I take nuclear, it's a little bit paradoxal, because, I mean, for decades, nuclear has been a huge user of computation power. If you think about simulation, if you think about design, so the CERN is in Europe where you have the biggest supercomputer, and all the nuclear industry is really very close to this very strong, I would say, digital 1.0 strengths. Now, if you move to the more recent advanced, we are related to open source, to very agile development, to open data, then industry like nuclear are sometimes not so comfortable, because there are specific regulation and specific habits that make it a little bit complicated. Let me give you an example. If you're doing a prediction on how people like a book or not, you can make 9 great recommendations and 1 huge mistake. If you're making a nuclear power plant, you can't make 9 great, hyper-efficient power plants and 1 catastrophe. So you need to change, to have a very specific way to roll out agile, cloud, and open data in a way that really secure what is very important, which is the physical security of your equipment. So this makes a difference, and this also explains why in the 2.0 digital, I would say nuclear is not for sure the last industry, because you have lots of engineers, a strong IT culture in nuclear, but probably not the most advanced because you need very often to have regulation. You have to have the regulator validating some application. So we see in a mixed mode. And so what do we see? So for example, for the conception and what we call the digital twin, we really see a development of this technology in nuclear. What you do with a digital twin is that you can have a double of your plant, so that you can solve problem even if you can't enter the plant, or you have specific problems that need that you understand all the history of the plant. For example, for decommissioning, you'll know precisely where there are hot zones where it's risky to send employee, and what are the best paths to ensure that they can do the decommissioning work without any risk for their health. So that's, for example, a technology we see developing. And we also see a lot in predictive maintenance. So using data so that you can fix machine before they break.
Thank you, Vincent. I have an additional question for you regarding the data management. You told us about the regulation and all the constraints that are applied on nuclear industry, and we know that constraint can be opportunities for innovation. My question is about data management, because the data is at the heart of the digital transformation. How is GE handling this data management? I will say outside the nuclear industry and for the nuclear industry, because we understand everybody here can understand that we have extra care to take off when we deal with data from the nuclear.
So first, the industrial and the consumer space are very different. In the consumer space, you see the GAFA, which business model is that they give you service for free and they take the value of your data. In the industrial space, you deal with much more rational players. So usually the model is you sell a service that lets your customer get the full value of his data. For example, when we're working with EDF, we're selling a solution, and then whatever profit, benefit, cost savings they do, they keep it for them. So this is a very strong difference because you are much more rational. Then when you go to security, it's really an architecture question. So the question is what you want to achieve, what is the risk, and what is the less expensive way to achieve what you want to achieve at the lowest possible risk. And let me give you a few examples. So for example, you have parts of the nuclear, in the nuclear industry, for example, dealing with nuclear military, which are very, very sovereign, and in which you might use a server, but it will be really a private cloud at most, and you won't do anything else. And now, if you look at the civil power plants, and you'll see parts for which you have the same constraints, and the regulator won't accept anything on a cloud that is not a private cloud or that is not localized in the country. It has a cost, but that's what you have to comply with. And then you see also other parts when you have a different architecture. Let me give you an example we just developed for an industrial customer. So this customer had plants for which they wanted to keep the data because they think that their data could show competitive advantage to potential competitors. And we use the cloud, but in a specific way, meaning that the data stays in the plant, is processed at the edge of the machine, but we're using the cloud to send the update of the analytics. So it helps this company getting the benefits of the cloud without endangering the security of the data. So very often what I see is mistake by people trying to have a unique solution and not wanting to enter into the architecture discussion and saying, okay, I want cloud, I want no cloud. No, that's not the way to address it. The way to address it is what is my problem, what are my constraints, and what are the different solutions, and what is the less expensive solution for me to reach my target.
Okay, thank you, Vincent, for this intervention. Franck Grimbert, you are the portfolio manager for the maintenance activity at Framatome. Thank you for joining us. You have a direct link to the field service. You are defining the technologies and developing the technologies that the team of Framatome are using on site. So my question, and after 2 words about Framatome activities, I think an update is necessary. Can you explain us today how the digital and the tools that you have developed at Framatome regarding those new technology have already changed the way the worker on sites are performing their tasks and their duties. And we would really appreciate, and that was one of the goals of this discussion, to have pragmatic examples of real application of digital behind all the buzz and the trends that you can see in the surrounding.
Okay. So first, I'm not in charge of all the Framatome R&D and innovation, only for the maintenance part, the maintenance business line. And but speaking about Framatome, obviously we have decades of experience in data analytics, and especially for long-term operation studies and all related to the aging of the nuclear power plants. So we are also developing things on these topics. Or obviously for digital control in INC, there has been a lot of improvement in the past years, and there are still improvement ongoing on site, where we are building new digital control for nuclear power plants. But in my case, and for your question, to answer your question, how we implement new technologies and new solutions on site. And in fact, it has begun more than 10 years ago. So before we were speaking about digital transformation, we were already trying to implement on-site new technologies. So it came through small examples using pads, for example. It was the first introduction of pads 10 years ago on some of our on-site operations. And we went step by step, taking these technologies and trying to implement them on our operations. When speaking about pads, I will take, as you mentioned, I will take real examples. We worked a lot the last years on what we call paperless solutions. So for the moment, it's still for our own use, but clearly we are working with our main customer EDF to implement solutions that we will be able to share documents with the customers, share all the signatures system that we need in our quality management. And all these solutions are currently under development and also under implementation. There are some specific experimentation in Blaye, for example, with EDF on these topics for paperless. But we are also working on helping the training of the people, and for that, since now more than 5 years, we are working on virtual reality and augmented reality as an help for the training. So we have some demos on the I2EN booth, where you will see some real application of RV and or VR and AR for the training. So this is already used, and we are also currently developing apps for helping the people on site. So the field workers, to give them more information at their working place, especially, for example, documents using virtual reality. So these are no more, I would say, buzzwords for our industry. These are real applications that we are putting on site.
Okay, you told us about augmented reality, virtual reality, about dematerialization of documents. Are those technologies today really deployed on site, and how the workforce is accepting or is, let's say, refusing this change of working? Do you have feedbacks about this kind of acceptance of the workforce? We know that the workforce is sometimes reluctant to new technologies, to new way of working. It's also for the engineering and for the whole chain of engineering a change. Is this change already accepted from the engineering team, for the field the field workers. Do you have some information to share with us about that?
Yes, clearly. In fact, we went step by step. For example, for pre-job briefing, we have used, as we said, I said before, we are using pads, and on these pads we were using 3D models to make these pre-job briefing. This was the first step to help the people being more used to this kind of new technologies and helping them to acquire the competencies to go inside the 3D model and to see what they will have to do with these using these 3D models. But when speaking about training, we performed the first trainings end of last year with using this mixed reality we have developed, and we will go on site with HoloLens or end of this year in October to perform a first of a kind using mixed reality on site to help field workers at their working place.
Okay. Thank you. So it's a reality today for your team to have.
So it's a reality. Maybe I did not answer your question regarding the acceptance for the workers. 2 years ago, we began an ergonomic study with different competencies we had in the field workers, and it clearly showed that people were very interested by the use of virtual reality. We did not see any drawbacks using these technologies, and they were even asking for more, saying, "Okay, it's very interesting for this kind of training, for example, but we would like to have it also on this and this operation for this and this kind of use." So they were at the same time helping us to draw the roadmap of our coming developments. So this is more or less very positive. I think these feedbacks to reinforce our roadmap.
Okay, they're pushing you.
Yes, we are pushing. We are pushing.
Okay. Christian Sora, thank you for joining us, and we are very pleased to have you on stage. Before you explain the activity of the I2EN, you are a hub. You were explaining that, and you are a bridge between the industrial and the academic world. Even if Frank already talked a bit about that, there is a big challenge in the nuclear industry about training, about knowledge management, and about transfer of all the know-how that have been acquired all those years of activities. Do you have already seen a change regarding training activities and all the things using the digital technologies? And does digital already change the game to train and to educate the workforce? I mean the existing workforce and the one that is coming in the coming years.
Thank you to welcome us. I2EN stands for International Institute of Nuclear Energy. That means nothing. In fact, we are a hub of education for nuclear in France. We have the industrial part with EDF, NG, all the major, and we work sometime with Boccard and other companies. And on the other part, we have high schools in France who have nuclear course to propose. So your question is very interesting, because if you look at the whole life of someone, when he's a kid today, what does it mean? He's connected 24/7 with his smartphone. He plays on the PlayStation, the Wii, I don't know, I don't play anymore. And he's connected 24. So his life today is connected. When he will arrive into the industry, he will have training, and his tools to work every day going to be more and more digital. But what's happened in the middle? When you go to school, when you go to university, and it was a question asked today we have some students from Le CNAM on a booth who help us, because Le CNAM is one of the partner of or associate of I2EN. And one answered me, "Oh, we use PowerPoint." No, it goes further than that. And in fact, because they make training during the studies in Framatome, in EADF, in Boccard, in every industry, they got the tools. And now they take these tools and use it and bring it back into the university to build their own course using the same technology. So the gap between the life as a kid, let's say, and the life as a worker, as an engineer, become more and more associated. It's very interesting.
Thank you, Christian. Frank talked a bit about it, and what about the just-in-time training, on-site training, and the what we could say the à la carte training that could be the change in the future world, and that's one of the key advantage of the digital regarding training.
I have a very good example, for example, for HPC, Uclay Point C, EDF Energy makes special, they adapt the courses for the students. You want to go to a classroom to have a traditional course, you go. But if you want to stay in your room on your bed and make a MOOC on your tablet, you can do that. It's very adaptive. You want to make the morning by your own and go to the afternoon. This is a really à la carte training. It's very innovative and it works very well because I talk with the people responsible of this program. The results are very, very high, much higher than a traditional course. So it's moving now, a little bit later than into the industry, but it's follow.
Okay, thank you. I have a question for all of you, and I hope someone will answer this question for. But we know that digital technologies are really based on mobility, on connectivity, and we know that all those technologies are not really fully accepted in nuclear power plants. So before we can extract all the value of the digital, we have to work on the mobility, on the connectivity inside the nuclear power plant. So I don't know if one of you has an answer about it, but do you think that in the coming years we will be able to have more connectivity, to exchange the data in a much easier way from the nuclear power plant to engineering sites, to headquarters, to be able to fully, I would say, to fully deploy the workflow process that is making our industry?
I may answer that to the Flamanville project we are finishing. And the way we design all the piping system has been entirely digital, in line with our clients, in line with our partners for the supply of the material and equipment. And when we were finishing with the engineering, we optimize our prefabrication in our plants in order to reduce the amount of hours to be done on site. And then the key was to be entirely seamless from manufacturing to construction. And we use our proprietary system called Boccard, which really gave heads view to our construction team to be sure to be ready with the right priorities in order to meet our clients' planning. And the Boccard allows through pads, and you mentioned pads, and for new build, we've designed, and we are one of the first one to use the pad on site, so our construction team will know exactly which piping system to be erected, which priority. And if they run into any issues, any problems, they could take picture with the pad and immediately download the problem to our engineering team, who would live treat the issue, respond, or decide to go to another priority system. So the seamless approach, reducing the amount of time for which we communicate, and also having the ability to have hands-on for those who are going to be erecting the piping system is a game changer, and it's improving not only the quality but also the productivity of our team. And that really is one advanced system that we are very proud and we're applying in most industries.
So if I may, I think it's also an interesting example of how technology is changing many industries. Because in this case, you don't see the technology pushing the people out of the plant. You see more an augmented employee using technology to do even more. And I can give a funny example of this. I don't know if you know a company called Julidesk. So Julidesk, they make an AI-powered assistant. So if you want to have an assistant, a cheap assistant, you contact this company and it will manage your mails quite efficiently. How does it work? It works with an AI, but also an army of human supervisors. And the net effect on job is more jobs. Why? Because people who could not afford an assistant for 200 euro a month can use this service, and through AI and people get an rather good service of assistant, not as good as an executive assistant, but for 1/10 of the cost. And what you see in lots of AI application in the industry, and especially in nuclear, is really what we exactly in the same kind. Using, for example, AI to eliminate 30% of the alarms that are not relevant, but ensuring that you have real people with a real sense of responsibility and a real adaptability to whatever could happen in a power plant that manage the real alarms. So I think this example of mobility just gives also a good feeling of how technology will develop in this industry.
Yes, for maintenance, mobility is really at stake. And more than mobility, what is very important is the possibility to communicate with someone who is outside the reactor building, for example, in the office and so on. And for the while, for example, Wi-Fi was not permitted in reactor building. It's improving. Now 2.5 gigahertz Wi-Fi is allowed, and 5 gigahertz Wi-Fi is ongoing to be allowed in almost all the plants. And using this kind of technologies, this will clearly give all the power to these devices, because if you are able to have these paperless solutions and having your network inside the containment and being able to send directly documents to the back office, then this will give really the power to these kind of solutions. So clearly, transmission and mobility are very important for having all the possibilities given by this digital transformation.
Thank you. Before we take your question on the text message platform and on the app, I have a last question for our contributors. As you have understood, and for this discussion, we really wanted to have the hint from the field and not talking about strategic digital transformation and big words. So we know that digital transformation is full of buzzwords, of trends, like we hear about deep learning, machine learning, AI, VR, and lots of other technologies that are coming up and then vanishing. So the question I have, and it's a prospective question for our contributors, is what is, according to you, the technologies that are today not really at a good maturity level for the nuclear industry, but that we should focus on because it will really add value to the nuclear and to the nuclear new build and the maintenance activities?
So this is a very good question, and of course it's difficult to make predictions about the future. But if I had to name a few technologies, so the first one would be IoT, and it's not mature, but today it's limited by the connectivity. So once you have connectivity, then you have a lot of application, and if you're in the technology, you better prepared for this wave. The second one is, of course, AI, but not AI in the sense of AI doing stuff, especially in the most secure parts, that will replace people. It's more augmented person. So how you can use the AI to simplify tasks that are really redundant, that are painful to do, so that people can be more alert to work on when there is a real problem. So for sure this will improve, but in a way that is not a robot replacing people, but what we call a centaur. You know this mythical figure of the centaur, half man, half horse. So we'll see digital centaur, half AI, half people. And then the third one is, I think, around the digital twin. So a nuclear plant, and we've seen it with Fukushima, is a place where sometimes if you have a problem, you don't really know how the place is built, how it changed with the time. And digital twin is this idea of having a digital double of your assets, of your plant, so that when there is a problem, you can understand problem without having to break a machine or to stop it, or when it's in a situation where it's difficult to enter the plant. So I'm pretty sure that this will develop, and this will develop all across the whole chain. So starting from the conception, the same model used in the operation and also used in the decommissioning of the nuclear plant.
I fully support what you have just said regarding IoT and AI. Currently, to give practical information, we are working on a chatbot for helping people on site to better detect failures in some systems. So this is still not mature. We are still working on, but we are confident in the fact that in the coming months, years, we have to master this kind of technologies for on-site people.
Well, one real-life application that we use, which bring a lot of new solution, is the digital twin approach to train our teams to prepare themselves for specific task. It's a very cost-efficient way of preparing and training our team when they have to go into areas where they're not familiar. Also, the augmented reality tools give us an access to information when we're in constrained location, and our team can really, without carrying a ton of documentation, can access through augmented reality and a database that it carries all the information on site during an act of maintenance, and it's really saving time and bringing more efficiency to the old way of doing maintenance.
And by the way, there is a very good demonstration of this on the Boccard booth today.
Thank you very much for the Itolad, and you're welcome to come visit and talk to our expert. We're just in front of the main entrance.
It's booth G15. Thank you. I really would like to thank all the contributors for this discussion. And before we take the first question from the audience, I would like, you had the mic, Mr. Boccard. I would like you to answer the last question. We are celebrating the first 100 years of Boccard. So you have 100 years of experience. So what is the vision of the future of the digital nuclear industry when fostering all this experience, and what is the vision of the future?
Well, for the nuclear industry, I would not talk for the nuclear industry, but at least for Boccard, our vision coming into our second 100 years of our life is to really focus on the digital solution, and we would like to become one of the leaders in the digital industrial solution. We've got the strengths, we've got the understanding, and we got the willingness and the partnership with some of the key players in the market to bring that new solution. But without the new team, the new generation coming on board, we won't do much. So we're looking for a new team to come and join the company to bring us to the next level.
Thank you, Bruno. We'll take the first question from the audience. Well, it was on the screen. Yeah, coming back. Thank you. So it's in French, but how the digital technology can help jobless people to find a new job in the nuclear industry. Christian, if you have a
yes, because maybe digital bring tools that are used in a lot of companies. and it can help to change or to find a job more easily. And if you have a lot of experience by using these tools or even develop these tools, it gives you more skills and more opportunities for that, of course.
Maybe what I would add is, at least for us, we don't really care to know if the person is jobless or not. The question is what talent he or she has and what he wants to do. And with digital, you have a full range of activities, from the person doing the UN supervision of AI. So you need skill, you need training, but you don't need a PhD. The guy who did the AI has a PhD, you don't need it for you. And of course, up to the industrial data scientist. So I think there is really a full range, and the question you should have is not, are you jobless or not? Is what you can do, when you can learn, and don't be shy, because there is really lots of opportunities for everybody. The just question is the will, the energy, and all this will change all the time. So the technology is changing. So don't be shy. Don't think, okay, I don't know the last technology. The guy who knows the last technology today, in 3 years, they won't know the last technology either. So let's go for it.
Yeah, I would like to really insist on what you said, that in the past, the IT people were in the back office. And today, because digital is so prevalent to the solution that we're providing, that suddenly the IT people are at the same level as people realizing and constructing and designing. IT is as much important to industrial solution as the welder or the engineer. And so the IT is moving now from the back to the front office, being part of the full team, bringing the full value.
Thank you for your answer. We'll take the second question. Thank you. The question is, do you really believe digital in new build fabrication will increase the productivity, and how to gain the delay for the next generation of EPR? That's a question for you.
Well, it's a question from EDF, I guess.
Because we have solution.
We have plenty of solution, and one of the key solution is to have the right tool to communicate with our client. So make sure we talk the same language, and when we say communicating, it's back and forth. And then using that information and have it entirely seamless in our organization in every step of the way we do the fabrication, the construction. But it's not only within our organization, it's also communication with our partners, because we need our suppliers, our subcontractors to be linked with the same system. We've designed a proprietary system called Boccard, which really guarantees that seamless communication of information and really optimize the access to the right information at the right time to the right people. I think that's one of the key aspects, because all those soft costs that are built between the different steps of the process need to be absolutely reduced, not only in delay but in actual cost.
Just for a number, I do believe that digital increases productivity. For G, each year it's bringing it's bringing 850 million of productivity each year. So it do bring some productivity. The question is really to invest in the right technology, raise the right engineer question, and not expect it to be magic. It's not just putting digital which makes things more productive. Putting the right technology on the right problem will make you much more productive.
Thank you. We'll take the last question for this session. What effort in terms of recruitment and training are needed to move to the digital era? That's a great question, because we know that the next generation, the coming generation of engineers and of technical workers will have this digital education. So,
to speak frankly, it's more and more difficult to tease young to come to the nuclear. So we have to make it attractive, and digital is certainly one way, the best today, to attract young talents, of course. We have to work on that, and as I told you before, the link between education and industrial world our job, of course, and we make it better and better, more and more communication, more and more exchange between, to make the connection between the two worlds.
Maybe one remark on training. First, 2 myths. First myth is only young people know digital. In fact, technology is really moving a lot, so people who left school 3 years ago need to go back to school. So it's not about, it's also not just about having the right training or being digital by construction. It's just learning the new technology over and over. Second thing, thinking that more experienced people are less digital. And in the Foundry, I can tell you, my head for engineering is 50. He worked in Alstom power and automation R&D for decades before, and he's very good, but also he has the mindset of being very curious, always wanting to learn the last technology. And to the contrary, I've seen a young guy in the interview who seemed not to have this curiosity of energy. So the question is not the age, the question is your ability to learn new stuff, because it's changing over and over.
I think it's a very exciting time for the industry and for nuclear industry in particular. That digital impact is a full game changer in the way we're going to approach the way we design, manage, and maintain industrial plants and nuclear plants. And it's attracting new talents and new mindsets. The technology is not the driving force, it's the mindset that goes with the openness of the technology that brings as a solution. And really we are excited about this ability of thinking differently and approaching a solution in a very innovative way.
Thank you, gentlemen, for this discussion. That was really an interesting moment. Mr. Vincent Champoin from General Electric, Bruno Boccard, chairman of the board at Boccard, Mr. Christian Sora, and Mr. Frank Grimbert, thanks a lot. I hope it has been a good time for you as well, and you are welcome on the booth of General Electric, of I2EN, and of Framatome, and of course of Boccard at the main entrance of the WNE. Thanks a lot.